All right, let's kick off this deep dive and journey back in time to explore some incredible prehistoric creatures.
Sounds exciting.
We've got fascinating research lined up, and I'm eager to learn not just what these creatures were like, but how they survived in their ancient environments.
It's like peeking into evolution's workshop, right? Seeing how life has adapted over millions of years.
Exactly. So, first stop, let's plunge into the Devonian period, roughly 382 million years ago, way before the dinosaurs roamed the Earth.
Back when the oceans were teeming with some seriously strange fish.
And at the top of the food chain was Dunkleosteus.
A true monster of the deep.
It's often described as a school bus with jaws. Can you paint a picture of this creature?
Absolutely. Dunkleosteus could grow up to 30 feet long.
Wow, that's massive.
And it wasn't just big, it was built for power. A real predator.
And what's really remarkable is this recent discovery, a remarkably well-preserved heart.
It's incredibly rare to find fossilized soft tissue like that.
A fossilized heart. That's amazing.
It is. And this heart wasn't just a simple blob, it was S-shaped with two chambers, a smaller one on top and a larger one below.
So even back then, hearts had a complex structure.
Yes, and for a predator like Dunkleosteus, this two-chambered heart was incredibly efficient.
I'm trying to picture how this heart actually worked. How did it help Dunkleosteus be such a successful hunter?
Well, think of it this way. The two-chamber design allowed for a powerful, rapid flow of blood.
So it's all about efficiency.
Exactly. This would have given Dunkleosteus incredible bursts of speed and energy, crucial for ambushing prey in the depths.
Like a supercharged engine for hunting.
Precisely. It's fascinating to see how this early heart structure paved the way for the more complex hearts we see in later animals.
It's like a roadmap of heart evolution.
Absolutely. From Dunkleosteus's two-chambered heart to the three-chambered hearts of reptiles and amphibians, and finally, the four-chambered hearts in mammals and birds.
So hearts evolved alongside the changing needs of different animal groups.
Exactly. It reflects the increasing demands of active lifestyles and warm-bloodedness.
Amazing. From a simple two-chambered heart to the complex four-chambered heart we have today.
It's a testament to the power of evolution.
Okay, we've explored the depths of the ocean. Now let's shift gears and head to land where the dinosaurs were taking their first steps.
Sounds good.
And we've got a new dinosaur on the scene. Embryrosaurus rothi, discovered in Zimbabwe.
It's always exciting to find a new dinosaur species.
So tell me about Barosaurus. What's the story?
Well, it was small, bipedal, probably an omnivore, kind of resembling a miniature Plateosaurus.
Interesting. So how does Umbarosaurus contribute to our understanding of dinosaur evolution?
It dates back to the late Triassic, a time when dinosaurs were just beginning to diversify.
Right, the early days of the dinosaurs.
And its discovery in Zimbabwe, along with similar fossils found in South America and India, suggests that these early dinosaurs roamed freely across the vast supercontinent Pangaea.
So these early dinosaurs were globetrotters.
It seems so. And what's even more interesting is that Marasaurus is classified as a sauropodomorph.
Sauropodomorph meaning?
It means it's an early relative of those giant, long-necked sauropods like Brachiosaurus.
Ah, those iconic long-necked giants.
Exactly. But Barosaurus, of course, was tiny compared to those behemoths, only about 6 feet long.
It's hard to imagine such a small dinosaur being related to those towering giants.
It is. But that's evolution for you. Humble beginnings and incredible transformations.
Okay, so we've met a supercharged fish and a tiny ancestor of giants. What else have we got?
How about a creature that has baffled scientists for decades? The Telemonstrum, also known as the Telemonster.
Monster, now you've got my attention. What makes this one so monstrously strange?
Well, picture this. A creature with a spindle-shaped body, a tail fin, 2 sets of fins, but no shell, no spine, not even an anus.
Sounds like something out of a sci-fi movie.
It does, doesn't it? For years, its classification was a complete mystery.
I can imagine. So how did scientists even begin to figure out what it was?
A recent breakthrough came with the discovery of a radula-like structure in its foregut.
A radula. Refresh my memory. What's that again?
It's basically a ribbon of teeth used for scraping and cutting food, a feature unique to mollusks like snails and slugs.
So are you suggesting this monster might have been some sort of giant sea slug?
That's the leading theory. And the way it might have used its radula is even more fascinating. Imagine it averting this ribbon of teeth from its mouth, almost like a chameleon's tongue, to capture prey.
Wow, that's wild. So from a predator with a supercharged heart to a possible giant sea slug, what's next on our prehistoric journey?
Let's switch gears again and head back to the Triassic to meet a tiny creature called Brasilodon quadrangularis, a shrew-like animal that lived in what is now Brazil.
Brasilodon. It's a mouthful. What's
Yeah.
so special about this little guy?
Well, Brasilodon might look unassuming, but it possesses a dental characteristic that has intrigued paleontologists. Diffeodonty.
Diphaeodonty. Break that down for me.
It means Brasilodon had only two sets of teeth in its lifetime. Milk teeth and permanent teeth, just like us.
Oh, like when we lose our baby teeth and get our adult teeth. What's so groundbreaking about that? Don't lots of animals have two sets of teeth?
That's the thing. Diffeodonty is a hallmark of mammals. It's strongly linked to the ability to produce milk.
Wait, so you're saying this little shrew-like creature might have been one of the earliest milk producers?
It's a fascinating possibility. This discovery could potentially push back the origins of lactation by a whopping 20 million years.
Now that's a game changer. But are scientists absolutely sure about this?
Well, Diffeodonty is a strong indicator, but more research is needed to definitively confirm Brasilodon's status as a mammal and a milk producer. It's definitely a compelling clue, though.
It's incredible to think how much we're still learning about the evolution of mammals.
Absolutely. And who knows what other evolutionary secrets are still hidden in the fossil record waiting to be discovered.
All right, before we get lost in speculation, what other incredible creatures are waiting for us?
How about a prehistoric giant otter? One that roamed East Africa millions of years ago and would have dwarfed any otter you see today.
A giant otter. Okay, you've definitely got my attention. Tell me everything.
This extinct otter, Enhydriodon omoensis, was discovered in the Omo Valley of East Africa.
And when you say giant, you mean?
Giant. Imagine an otter the size of a lion.
Whoa,
Yeah.
that's massive. How big are we talking exactly?
This behemoth is estimated to have weighed over 200 kilograms. That's over 440 pounds.
A 400-pound otter. I can't even imagine encountering something like that.
And it wasn't just bigger. It's thought to have spent more time on land than modern otters, and its diet wasn't limited to fish.
So this wasn't just a scaled-up version of the cute, playful otters we see today.
Yeah.
What was on the menu for this giant otter?
Well, it had powerful teeth capable of crushing bones, which suggests it might have scavenged or even hunted small animals.
So early hominids might have had to watch out for this massive predator.
It's a fascinating thought, isn't it? Imagining early humans navigating a landscape shared with these giant otters.
It really paints a picture of a very different world.
It does. And one more intriguing detail about Enhydriodon. Isotope analysis suggests that it wasn't entirely land-bound. It still spent a considerable amount of time in the water.
So, a truly versatile predator.
Absolutely. Comfortable on land and in water.
It just goes to show the prehistoric world was full of surprises, and sometimes the most unassuming creatures have the most remarkable stories to tell.
And we're just beginning to uncover them. It's like opening a window into the past, isn't it? Each discovery reveals a new piece of the puzzle.
Absolutely. And speaking of puzzles, there's a long-standing mystery surrounding the origin of those bird-hipped dinosaurs, or ornithischians.
Ah, yes, the ornithischians. Think Triceratops, Stegosaurus, those iconic dinosaurs with beaks.
Right. But their early evolution has been a bit of a head-scratcher for paleontologists.
It has. But recently, there's been some exciting near evidence.
So have they found the missing link? What's the latest scoop?
Not a single missing link, but a whole group of reptiles that might hold the key. The Silosaurids.
Silosaurids. Those don't ring a bell. What were they like?
Imagine them as the quirky cousins of the dinosaurs.
Quirky cousins. Okay, I'm intrigued.
They weren't dinosaurs themselves, but closely related. And they had some curious features that hint at a transition to true ornithischians.
Like what? Did they have beaks too?
Not quite beaks, but their teeth were adapted for a herbivorous diet, similar to many ornithischians.
So they were already munching on plants way back then.
It seems so. They had leaf-shaped teeth with wear patterns that suggest they were grinding up plant matter.
So like the vegetarians of the Triassic period.
Exactly. And there's another intriguing clue, their hip bones.
Okay, I'm all ears.
Some coelosaurids, like a species called a Silesiosaurus, had a bony projection at the front of the pubis called a prepubic process.
A prepubic process, all right?
Yeah.
Why is that significant?
Well, this same bony projection is also found in early ornithischians.
Ah, so a shared skeletal feature. That's pretty compelling.
It is, and it suggests a close evolutionary relationship between the two groups.
So are scientists saying silosaurids were the direct ancestors of ornithischians?
It's still a matter of debate, but a recent study proposed that silosaurids should be considered early members of the ornithischian lineage, not just close relatives.
Wow. So these quirky cousins might actually be the ancestors of all those iconic bird-hipped dinosaurs.
That's what some scientists are suggesting. And if it's true, it means the split between the two main dinosaur lineages, the Ornithischians and the Saurischians, happened much earlier than previously thought.
That would be a major rewrite of dinosaur history. What about those silosaurs that weren't strictly herbivorous? How do they fit in?
That's where things get even more interesting. Remember, evolution isn't always a straight line. It's possible that the earliest ornithischians, like Silosaurus itself, might have actually been quadrupeds.
Really? I always pictured ornithischians as being bipedal, like Triceratops.
Exactly, but it's possible that bipedalism evolved later in the ornithischian lineage.
So we could be looking at a scenario where the first bird-hipped dinosaurs were four-legged plant eaters, gradually evolving into the diverse array of bipedal herbivores we know and love.
Precisely, and it's important to remember this is still a very active area of research.
Always more to learn.
Absolutely. New fossil discoveries and analyses are constantly refining our understanding of dinosaur evolution.
Okay, so we've got some intriguing leads on the ancestry of bird-hipped dinosaurs. What other prehistoric mysteries are we tackling today?
Let's go back to those armored fish we talked about earlier, the placoderms. Remember Dunkleosteus with its incredible heart?
Oh yeah, the school bus with jaws. What about them?
Well, it turns out their jaws were just as remarkable as their armor.
Okay, lay it on me. What was so special about their jaws?
Unlike most fish, which have jaws that hinge at the back of the skull, placoderms had jaws that hinged near the front.
So their jaws opened at the front. That seems a bit backwards.
It might seem strange, but this forward hinging jaw mechanism gave them a tremendously powerful bite.
Interesting. So how did this unusual jaw work in action?
They could actually protrude their lower jaw forward, creating a powerful shearing force.
Like an underwater guillotine. What were they eating that required such a powerful bite?
They were top predators. Their menu included other fish, crustaceans, and even those tough, hard-shelled mollusks.
So they were the ultimate prehistoric eating machines. Armor, powerful jaws. What else did these placoderms have going for them?
Well, their armor wasn't just for protection, it also played a role in their agility.
Really? I always imagined them as being slow and cumbersome.
Some placoderms were definitely heavily armored and not the most agile, but others, like Dunkleosteus, were likely quite nimble.
So more like high-tech tanks, well-protected but still mobile.
Exactly. Their armor was surprisingly lightweight and articulated, meaning it had movable joints.
So they weren't just clunky suits of armor, they had a good range of motion.
Precisely. It's incredible how evolution comes up with so many different solutions to the challenges of survival.
Agreed. Okay, what other fascinating adaptations have you uncovered from the prehistoric world?
How about a creature that looks like it belongs in a Dr. Seuss book? The Tinistrophids.
Tinistrophids. No, those don't sound familiar. What's the Dr. Seuss connection?
These reptiles, which lived during the Jurassic period, are famous for their incredibly long necks.
Long necks like giraffe.
Even longer. One species, Tanistropheus, had a neck that was 3 times longer than its body.
Wow. What were they doing with necks that long?
That's the big question. For years, scientists debated whether they were primarily land-dwelling or aquatic.
So a tug of war between land and water. Which side won?
The evidence points towards an aquatic lifestyle for Tinistropheus.
So team aquatic it is. But how could something with such a long, seemingly awkward neck be a good swimmer?
Well, their necks weren't as cumbersome as you might think. They had a unique arrangement of vertebrae and ribs that provided both flexibility and support.
So like a flexible but sturdy scaffolding.
Exactly. Strong enough to hold their heads up, but flexible enough to maneuver in pursuit of prey.
I can picture them now, graceful, prehistoric, serpent-necked swans gliding through the water.
A great analogy. And those long necks weren't just for show. They likely helped them ambush prey, darting out to snatch fish or other aquatic animals.
Like a prehistoric fishing rod. Okay, that's definitely going on my list of things I wouldn't want to encounter while swimming.
But seriously, it's a brilliant adaptation and a great example of how evolution can lead to some truly remarkable and unexpected results.
Okay, we've had supercharged predators, giant sea slugs, and now swimming reptiles with necks longer than their bodies. What else is in store?
How about a group of dinosaurs that took social behavior to a whole new level? Get ready to meet the hadrosaurs.
Hadrosaurs, those are the duck-billed dinosaurs, right?
That's right. They thrived during the late Cretaceous period. They're famous for those distinctive duck-like bills, but their social lives are what's truly fascinating.
So they weren't just munching on leaves all day. What kind of social butterflies were they?
Well, they lived in large herds, and they had some pretty elaborate ways of communicating with each other.
Really? How so?
Many species had hollow crests on their heads, and these crests may have been used to produce various sounds.
So they were like the orchestra of the dinosaur world. What kind of tunes were they playing?
They could have been anything from warning calls to courtship displays, even simple greetings.
I can just imagine a herd of hadrosaurs, their crests, resonating with a symphony of sounds.
It's a fascinating image, isn't it? And the crests weren't just about sound. They likely played a role in visual communication as well.
Okay, how so?
Well, the size and shape of the crests varied widely between species and even between males and females.
So it was like a prehistoric fashion statement, each species with its own unique headwear.
It's possible, and those variations might have helped individuals recognize each other or assess the age and social status of others.
Like a dinosaur social hierarchy, all displayed through their crests.
Exactly. And there's more. Fossil evidence suggests that hadrosaurs were also devoted parents.
Oh, tell me more.
Nesting sites have been found with multiple nests clustered together, which indicates that adults might have cooperated in raising their offspring.
So they weren't just social, they were community-minded.
It seems so. It really paints a different picture of dinosaurs, doesn't it? Not just solitary beasts, but creatures capable of complex social interactions.
Absolutely. It's like looking through a window into a lost world and realizing that dinosaurs were far more dynamic and fascinating than we ever imagined. It's amazing to think about those dinosaurs, not just as big scary lizards, but as complex social creatures.
Right. They were more than just teeth and claws.
Absolutely. Earlier we talked about the Tenistropheus, that strange reptile with the ridiculously long neck.
Ah, yes, the Tenistropheus. Quite a puzzle, that one.
You mentioned scientists debated whether it lived on land or in the water.
That's right. For a long time, it was a real head-scratcher.
So a prehistoric mystery. What was the final verdict? Land or water?
Well, recent studies have provided strong evidence for an aquatic lifestyle.
So it was a water dweller. How did they finally solve this mystery? What tipped the scales, so to speak?
A combination of things, really. First, its bone structure.
Okay, what about it?
Its limbs were relatively weak, not ideal for supporting its weight on land.
Ah, so not built for walking around.
Right. But its tail, on the other hand, was long and powerful, suggesting it was used for propulsion in water.
So built for swimming.
Exactly. And then there's the inner ear.
What about it?
The inner ear is responsible for balance and orientation, right?
Right.
Well, in Tenistropheus, the structure of the inner ear was very similar to that of aquatic reptiles.
So even the inner ear gives us clues.
It does. It suggests that Tenistropheus was adapted to life in water, navigating that three-dimensional world.
Amazing.
Yeah.
So we know it was a swimmer, but how did it actually use that super long neck? Just for reaching food on the seafloor?
That's a good question. Scientists have come up with some fascinating ideas.
Okay, on all ears.
One theory is that Tenistropheus used its neck for ambush predation.
Ambush predation.
Exactly. Imagine it lurking in the depths, body hidden, and then boom, it quickly extends its neck to snatch a fish or squid.
Like a prehistoric harpoon. That's incredible.
It is. Another possibility is that it used its neck like a periscope.
A periscope.
Yeah, to scan the water for prey. With its head held high, it could survey a wide area looking for signs of food.
So a stealthy hunter with a built-in periscope.
It really shows how evolution can produce these incredible adaptations, allowing creatures to thrive in their environments.
It makes you wonder what other bizarre and fascinating creatures are still waiting to be discovered.
I know. The fossil record is full of surprises, and with every new find, our understanding of the prehistoric world expands.
Well, on that note, we'll wrap up this deep dive into the world of prehistoric creatures. It's been an incredible journey.
It has.
We've seen supercharged predators, giant sea slugs, four-legged ancestors of triceratops, otters the size of lions, and swimming reptiles with necks longer than their bodies.
And we've only just scratched the surface.
Exactly. Who knows what other wonders are still out there waiting to be unearthed? So keep those minds curious, keep exploring, and maybe, just maybe, you'll make the next big discovery. Until next time.